Hello everybody, my name is John and I am from Studio Digital Resin, and today I am going to show you a quick demonstration, or hopefully a quick demonstration, on how to create circles. So that's the GxCircle command using AGX for AutoCAD. Now the demonstration is going to eventually take us to this drawing here, and I will show you, hopefully if I have enough time, how to create something like this. This in normal AutoCAD would probably be virtually impossible to do without some kind of a geometric parametrics which allows you to create geometry which is reliant or dependent on other geometry. So this is the power of AGX. It allows you to create things like this and actually modify it in real time without you having to manually go through each entity and modify it once other aspects of your design have changed. Right, so I'm just going to close that drawing down and create a new one. Okay, so what you need to do is if you type in GX in the editor window, it will show you all commands starting with what you've typed in. So all AGX commands start with GX. Now GxCircle, when you type that in, you will get three options underneath by script. By script is not yet implemented. This will allow you to create geometry based on a programming script. It allows you to create geometry based on formulas, if you may have it, or other methods. So the first option is by center point and radius. So you create a circle, you select a center point, which is a GX point, and you type in a radius. The same with center point and diameter. You just specify a diameter. And center point and radius point, it allows you to specify a radius point, which will determine the length of the radius, and you can then control the size of your circle by dragging that point. So all of these three methods require a point, and it's not an AutoCAD point, it's a GX point. So if you type in GX point, the default method for GX points is just to click anywhere, and you get points. Now you'll notice that these are the standard. This is the standard layout for AutoCAD when it draws points, and you can change that by typing in DDP type, and then you can select another way for AutoCAD to draw points. So I'll use the crosshairs. So now we have 2 points here, so you'll notice that if you hover over any GX entity, you get a name and some extra properties which relate to that point. Every GX entity has a name, and this is because all GX entities you can reference them by other entities as well. So you can refer to the properties of one entity to control or drive the properties of another entity. Right, so let's just get into creating a circle. Type in GxCircle, and we'll choose center point and radius. You select the center point, type in a radius. Now offset values, you get 3 offsets. You get the X, so you can create it X number of units away from along the X axis, or I'll choose 0 as the default. Along the Y axis, I'll choose 0 for now, and also along the Z axis, I'll choose 0, and there you have it. There you have a circle. If you select the center point and move it, then the circle moves along with it. Now let's create a circle by center point and diameter. Select your center point and type in a diameter. You get the same options. You get your offset options. I'll choose 0 for now. And there we have a circle of the same size, just created by diameter. And now let's do the third by center point and radius point. So I'll pick this point as the center point and this point as the radius point. Select the defaults. So now what has happened is AGX will create a circle whose radius is the distance between these 2 points. So if you modify this point, you can see what's happening. The third circle is obviously adjusting to the size of the distance between the points. Now, one thing that's different between the built-in parametrics of AutoCAD and AGX is that AGX works fully in 3D. So what you'll see now is if I move this point along the z-axis, is the circle will float in relation to, again, the axis created by the invisible line between these 2 points, so that the circle remains on that point. Now this is useful if you need to be able to control how a circle, or the direction in which a circle faces. By moving the radius point, it creates an imaginary plane on which to create the circle. So that plane is actually the cross product between the normal of the center point. So the normal of this center point, which is actually a planar entity, is vertical because it's flat on the xy axis, and the vector between the start point and the radius point creates another line which is the, I suppose, one of the u-axis on the plane. So what it does is it uses the cross product between the normal of the start point and the vector between the start and the radius point to create the v-axis of the plane. So if I rotate this around, you will notice that, well, it's actually difficult to see where the axis of rotation really lies, but that's the mechanism that it uses. And I'll actually show you when I showed you in the previous file how the actual center point calculation of the plane for the circle is determined by the orientation of this point in itself. Okay, if I go back to top view, now you can see it looks a bit like an ellipse because it is floating in 3 dimensions. Right, now to create a spline, we need points. So if I type in GxPoint, I'll just create a spline out of 3 points, and another spline just below that out of 3 points. If you type in GxSpline, create by fit points. It only has fit points at the moment. You get prompted to select your first GX point, and your second GX point, and third point, and so on, and enter when you are finished. This message is actually incorrect. It should be close the spline. We don't want to close the spline, so there you go, you have a spline, and if you hover over it, you will see it has a name, GxSpline 01. I'll create another spline. No. So there we go, we have 2 splines, and these splines are also controllable by their fit points. There's no other way to control the spline other than by moving its fit points. Right, so now, how do we create points along this spline so that we can create circles using those points as their center point? Well, the GxPoint command has a multitude of mechanisms to create points. If you hit the down arrow, you'll see there are 8 of them. The one that we're interested in now is in Bayes by curve. So this allows you to select a curve. And a curve is anything that's a circle, a line, a spline, a polyline, or an ellipse. They're all curves. And then it asks you for the number of bays. Now a bay is just a a subdivision of the actual curve in itself. So if you have 10 bays, you will actually have 11 points. Let me show you that. So it asks you to enter in a number of bays. 2 is the default. 1 bay is really just a point at the start and the end. So if I select 10, now include start, I'll select no, and I'll show you include end. I'll show you what that means. So we have 10 bays along this spline. The subdivisions don't look equal. That is just because that's the way AutoCAD subdivides splines. There is no perfect equal mechanism of subdividing splines. So here is the first bay. There is no point at the start of the spline. Here is the second bay, third bay, the fourth bay. This mechanism may be renamed so that it is by point divisions, but it's by bays on a curve for the time being. So what has actually happened now is you've created only one GX entity, one GX point, though because of the mechanism by which we created the point, it has created 9 sub-objects, and these are all under the control of that one single entity, and they all start from the start of the curve on which they rely. So this point is called GxPoint09, and you can see the 0 index next to it. That is the first object, the first sub-object of GxPoint09, and this one will be GxPoint09 number 1, GxPoint09 number 2, and so on. But they're all part of GxPoint09. What this allows AGX to do is if you create a GX entity that relies on a point, it will then replicate that entity based on the number of the points which you have specified. So just to show you, I'll create a circle by center point and radius. I'll choose the center point. You can choose any one of these because they all belong to the same ultimate parent GX entity. The radius, I'll put 100. Faults for the offsets. Oh dear, that's too small. But in essence, there they are. So this will now be GxCircle 04, and the first one. 0 is always the first index. And this will be GX01. So now these AutoCAD circles are now under the control of one single GX entity. If you type in GxCP for control panel, so the control panel is what you will use to modify the properties of the GX entities. So if you select one of the entities, its properties will appear here on the left hand side or wherever you have docked it. I'm just going to modify the radius because the circle is a little small, and then you will see that we now have a visible circle. So the actual, when you create a point on a curve, the point is created perpendicular to the direction at that point on the curve. It doesn't face up, it doesn't face down, it's created perpendicular to the curve itself. And when you create anything that relies on a point, the object itself will be created on the same plane as the point. So the circles now sit basically perpendicular to the curve, and they're all the same size. And if you look from top view, you will notice that they are all perfectly vertical. And if I modify the spline, let's move this fit point along the vertical axis, we'll see that they all move along with it, and they also adjust according to the new planar direction of the point. Now this would be virtually I've never tried to do this in AutoCAD by itself. I don't even know if it's possible. And especially not possible to simply drag things around quite quickly until it looks good to where you need it to be, and then have it all recreated instantly. Okay, so that's by center point and radius point. Center point and radius. Now let's use the radius point mechanism, and I just want to show you what that yields. So I'm just going to get rid of these circles. Okay, now we're going to need to create the same number of points on this spline, and then this spline will be used to control the length or the radius of each circle, and it will differ. GxPoint, by bays on the curve, pick this curve, it was 10 bays, include the start, no, include the end, no. I need to fix that prompt, it should say include end. GxCircle by center point and radius point. We'll choose these points as the center point and these as the radius points. The defaults for the offsets. And there you have it. Now each circle is attached to the radius point. And you will also notice, however, that their direction is not the same as the direction of the center point. That's because the mechanism used to create the plane on which the circle now resides is different to the way the standard circle is created, because it has to find the most appropriate plane which is controlled by the axis between the center point and the radius point, and then the best way to rotate it along that axis so that it's at least controlled by something else, and that is the cross product of the normal of this point. And it's difficult to actually visualize. I mean, this may change, but it was the best way to try to create the correct plane on which to control the actual the circles themselves. So if we go and modify the radius point curve, you'll notice how all the circles will adjust and remain fixed or stuck to their individual controlling points. So if you ever need to have geometry which is controlled by a curve, or geometry that is centered or lies on a curve, this is one mechanism in which you can create circles that rely on points that are placed on a curve. Right, so I think I'm going to have to cut this video short. It's already been 19 minutes. I will have to make another one to demonstrate this a little bit further, just to show you what sort of things that you can actually achieve with this. Okay, so please, it's been nearly 7 months since the last video I did. That is because this product is really complex, and it's trying to fit in so many things all at once. But that sort of power is really beneficial. So more than likely I will do the next video on points themselves, and I need to explain each and every GX entity one by one, but they all quite tie into points, and the power of being able to create points in ways which you cannot do normally in vanilla AutoCAD. So please stay in tune for the next video from Studio Digital Resin.